Hi everyone. Okay, so this week's work for hire is going to be all around something called the Standard Model of Fundamental Particles. So you can see the learning intention for this week is just that that's what we're learning about. And the success criteria, you will notice, looks a little bit different from our normal success criteria. Normally in physics we wouldn't have so many states. However, the nature of the standard model and what you need to know about it is basically just a lot of knowledge, a lot of being able to state what is meant by some different terms. So you can see here there'll be a lot of sort of new words, I would imagine, to most of you, and annoyingly a lot of similar sounding words like fermion, boson, hadron. However, your task this week ultimately is to learn what all of these terms mean and be able to describe the differences between them. Okay, so I'll not go through this, but you've got your success criteria to look at throughout the week just to keep you on track. But there is a lot of state there, so please just make sure that you are trying to learn that as you go. So your tasks for this week to help you achieve this can be found here. So this is your checklist, if you like, for the upcoming week. There's lots of different activities and resources found in this checklist, and it is important that you work your way through them all. We've set it up this way to hopefully make it a little bit easier and break it up into chunks to keep you right in what you have to do. So like I say, we're learning about the standard model. There is a very short video. It's about 5 minutes long that just introduces what the standard model is. And I'll just do a brief introduction just now for it as well. So the standard model is one of these annoying things where we've kind of lied to you in the past. So in first and second year, we talked about the atom being the sort of building block for matter. As you moved into third, fourth, and even halfway through fifth year, we've talked about the atom being made up of smaller particles, protons, neutrons, and electrons. We're now going to dig a bit deeper. The standard model actually breaks that picture up even further, and it gives a list of basically what we say is fundamental particles that make up all matter. Now, that word fundamental is going to be really important for you because as you're working your way through, that's all of these words that you can see on the screen just now are talking about fundamental particles. And fundamental just means can't be broken up anymore. So it's as simple as it will go. So what we've got here is probably a scary looking picture, but it's actually quite a nice picture because what it does is it arranges all the fundamental particles that make up all of the matter. And this picture here just kind of puts it into nice little groups for us to manage. So your task this week is to familiarise yourself with everything on this screen and learn a bit about them. So like I say, I'm not going to do an hour-long lesson on this. I'm just going to briefly introduce you to it so that you've got a starting point. But what we've got here in the sort of purple is a family called quarks. And there are 6 of them. So you will need to learn what the name of the 6 of these quarks are, but you also have to give some information about them, such as the charge. Now, you will see they've got the names of them. We've got up and down, charm and strange, and top and bottom. And as you're going through the tasks this week, like I say, you'll learn a bit more about them, but that's our 6 quarks. Our next sort of family, our green group, are called leptons. And I would imagine you'll all be familiar with at least one of these, which is the electron. But there's some other leptons in here as well that you're going to learn about. And the kind of reddy pinky group is our bosons, which there are 4 of them. And then in addition, the Higgs boson, which I would imagine you have all heard about and you will learn a bit more about throughout your tasks this week. So this is the picture of the standard model of the particle. So this is what scientists or physicists have sort of broken down all matter to be made up of these fundamental particles. You'll notice that nowhere here is the proton or the neutron. which tells us that the proton and the neutron are actually made up of even smaller particles. However, the electron is here, which tells us that that is actually a fundamental particle. So that was a very, very brief introduction, but like I say, all of your work this week is going to take you through that. So if it doesn't make sense just now, hopefully it will after you complete the tasks. So first of all, watch this short video clip about the Standard Model as an introduction. The next thing we'll ask you to do is if you can read through pages 5 to 12 of your Particle and Waves notes booklets. These are the booklets that were issued to you in December, but don't worry if you don't have a copy. We've also added a digital copy into the Files tab on Teams, so you still have access to it. Anything on the checklist that's in green just indicates where you can access the resources if it doesn't have a link on it. So read through pages 5 to 12 of your notes. You can also use BBC Bitesize, and there's a link here to where you can find those notes, and info can be found on the sections 2 to 5. Again, it's the same information, but just in a sort of slightly different format. We have also added a few PowerPoints that we would normally be using if we were in Classroom into the Files tab on Teams. So again, just use this to kind of supplement what you're learning about. We've found that the sort of most effective way to learn about the Standard Model is to create flashcards on it, because there is a lot of terms and they are similar sounding. So flashcards is a really good way to just sort of help you learn them and get used to them in terms of using them in the correct context. Now, in the Files tab in Teams, we've got a blank template for you. If you've got access to a printer, you can print it out or you can type onto it. There's also a copy with answers to keep you right. Or if you prefer to do it digitally, we've provided a link here to a Standard Model virtual card sort, which has already got the cards made up for you. Again, kind of similar to the last one, in Quizlet, we have made up some flashcards for you, and it allows you to do sort of different activities. And you've probably used Quizlet before, but the flashcards have got your different terms for the Standard Model, and you can do a variety of things with that. You can just do a recap, you can do a quiz or a game. Now, if you have access to an Apple device, so iPhone or iPad, there is a really good app called Particle Zoo, which I can show you just now. Here it is. And what it does is it just gives you a list of each of your fundamental particles, and if you click onto it, it gives you some information about them. And again, it's just another sort of resource that you can use to help you as you're going through your work through the week. It is only available to Apple for some reason, but don't worry if you don't have Apple, it's just another sort of thing to help. Again, there is a memory quiz being made up for you here, so you can probably see there's a bit of a theme going on with the work that's set, a lot of sort of memory and testing yourself, because it is ultimately just knowledge this week. There's nothing in the way of equations or application. It is literally, you just have to learn a lot of these new words and what they mean. Now, hopefully after you've completed all of these resources, you will be ready to try some questions by yourself. So as usual, we would be working on the problems just like you would be in class. We never gave you the booklet for the problems before finishing up, but we have saved a digital copy in Teams in the Files section. So you should now be in a position where you can complete the questions on pages 5, 6 and 9, not 7 or 8, 5, 6 and 9 in Problem Book 1, and that can be found here. As usual, the answers are uploaded as well, so I've actually saved that as a separate document just to keep yourself right. And as usual, we would expect you to work your way through the questions and then check your answers as you go, just to keep you right. Again, at any point you come across a question, just like if you were in class and you're not sure how to do it, you just put a note on Teams, get in contact with us, and either myself or Mr. McFarren will get back to you. Once you've completed those problems, or even as you're completing the problems, we would like you to upload them using the Assignments tab. And as I sort of outlined in the introduction, this is really just so we can make sure that you're getting on okay with the work, that we can provide any feedback on your working, or even just some encouragement to tell you that yes, you're on the right track. So please make sure you are doing this. Now, as will be the case with every week, your final task is going to be to complete an assignment, which is normally going to be a Microsoft form. So that will be made available later in the week, just to make sure that you have plenty of time to complete all of these tasks. Please bear in mind this is 5 periods worth of work, so it isn't going to be done in the first day. It shouldn't be done in the first day. But again, we're giving you this all out on a Monday to allow you to sort of manage your time based on your own circumstances. So please don't just come on, have a look at the checklist and then try and jump to the assignment and think that's your work done for the week. It's not, and it won't work out well. So you need to make sure you are working your way through each of the tasks, that you are completing them the best you can, and you are asking for help where needed as you work your way through it. Okay, so this is for this week. We've set a deadline on the assignments as midnight on Sunday. Again, just to give you that flexibility in case you can't get access to a device during the week. We would advise you though to be working on it throughout the week, ideally at the times where you would normally have physics. If you have any questions about any of the work that's set out or anything as you go through the tasks, then please get in contact. Okay.